Hello, this is the second video in a series on parabolas, and this video is focusing on parabolas that have been shifted from the origin. So the vertex is at some point hk. I put this down here just as a reminder that a parabola is defined as a set of points that's equidistant from the focus and the directrix. So when we're characterizing parabolas and identifying them, we want to find the focus, we want to find the directrix, we want to find the vertex, and we want to find a couple points on the parabola, which usually we do with the lattice rectum. Okay, so we have two standard forms of parabolas. We have this y minus k squared is equal to 4x minus h, and we have this x minus h squared is equal to 4p y minus k. So these x squared ones are opening up or down. These y squared ones are opening left or right. Our vertex is always going to be at hk. And then we're going to move to our focus. We're going to move p to our focus and p to our directrix. So our focus becomes h plus pk, and our directrix is h minus p for our y squared ones. And then from our focus, we're going to move 2p in the y direction, in this case, to get to the endpoints of our lattice rectum. If it's x squared is opening up or down, the focus we're going to move up or down, so we're going to add p to our k value to get to our focus, and we're going to subtract p from our k value to get to our directrix. And again, our lattice rectum, we're going to move 2p in our x direction to get the endpoints from our focus to get to the endpoints of our lattice rectum. I have this link in here. It has, I really like this table because it has both the equations and the graphical representation. So this is here if you want to use it, if you want to take a look. I am going to go through a couple of examples using both the equations and graphically how we get there. Okay, so we have this equation that is x minus 2 squared is equal to 4y plus 1. So the first thing that I do is identify we have x squared. This is going to be opening up or down. And this, we have 4p is equal to 4. So my p is equal to 1. And my vertex is always hk. So x minus h is 2, y minus k. This has to be -1, so we change the sign. So this is our vertex, okay? Our p is equal to 1. I'm going to go ahead and plot my 2, 1 here. Let's see. Is that okay? We have 2, 1 is our vertex. So I've plotted that already here. I said that we're opening upwards and we're moving 1. So if we move 1 up, we're going to get to this point here, which is 2, 0. And our vertex was 2, -1. If I'm doing, so that's graphically. I just look at the graph, I go up 1, I find out what point I'm at. If we want to use the equation, this is hk plus p. Well, we said h was 2, focus. H was 2, and then k is -1 plus p plus 1. So this is equal to 2, 0. Okay? We can get it the same both ways. Okay? Our directrix, we're going to go down 1. So we're going to go here to this line here is our directrix. So we go down 1 to get to our directrix. So this is our y is equal to -2 line. If we want to do that algebraically, we have y is equal to k. What we said k was -1 minus p minus 1, or y equals -2. This is our directrix. Okay, this is our focus. And we had our vertex here at 2, 1. Okay, so now we want to find our lattice rectum, the endpoints of our lattice rectum. And I'm just going to do this in pink. So we need to move 2p from our focus. So if this is our focus, we're moving 2p, which is 2. So we're moving to here. This point is 4, 0. And we can move 2p this way, right here. So we move 2 in this direction. That is 0, 0. If we do that algebraically, we have h plus 2p, k plus p. Well, k plus p we know is 0, so we know that they're going to have the same y value as our vertex, as our focus. And then h plus 2p, our h was 2, plus 2, and 2 minus 2. So this becomes 4, 0, and 0, 0. Okay, so now we pretty much have what we need to be able to sketch this parabola. You can draw a smooth parabolic curve through these points. You can probably do a better job on your paper than I do on my screen, but that's what we need to do for all of these. Okay, so we find our vertex, we find our focus, we find our directrix, our lattice rectum. Take a look at another example that's more of the y-squared variety, but also if we're given a standard equation. So I'm going to go through this pretty quickly, but we're going to complete the square for this. So the first thing that I want to do is I want to get all of my y stuff on one side and everything else, all of my x and my constants on the other side of the equation. So I'm going to subtract 4x plus 7 minus 4x plus 7. So I'm going to write y squared plus 2y. I'm going to leave some space. Equals negative 4x plus 7. Okay, so now I want to complete this square. I'm going to divide this 2 by 2. That's 1, and 1 squared is 1. So I'm going to add 1. To maintain the equality, I have to add 1 to this side. So I get y squared plus 2y plus 1 is equal to negative 4x plus 8. So I recognize this. I designed this to be a perfect square that squares y plus 1 squared. Sorry about this. And this is equal, I'm going to factor out a negative 4, and I get an x minus 2. Okay, so now I have this in a standard form that I can look, that looks like this. This y minus k squared is equal to 4p x minus h. Okay, so I can say that my vertex is at 2, negative 1. I'm going to plot this over here. And I'm going to say that negative 4 is equal to 4p. So p is equal to negative 1. So I'm going to move negative 1 to get to my focus, which is here, right? Which is, my focus is at 1, negative 1. If I want to do that algebraically, it's h plus p. So my h was 2 plus p plus negative 1, comma k, negative 1. So this is equal to 1, negative 1. Okay? I'm going to move 1 in the opposite direction to get my directrix. So we have a line here at x equals 3, or x equals h minus p. So h was 2 minus negative 1. So it's 2 plus 1 is x plus 3. Okay, now for my focus, I'm going to move up 2 and down 2 to get to my endpoints of my lattice rectum, because my p is 1. So I need to double that. Okay, so this was 0.11, and this point is 1, negative 3. Okay, and you can use this formula to get there as well. I'm graphic. I like to do it this way. And now we have enough to do a rough sketch of this parabola. Okay. So here we completed the square to get to our, we completed the square to get to our standard format. We found our vertex, and we found our focus and our directrix, and then we found the endpoints of our lattice rectum. Okay, so those are the steps that you want to go through to graph a parabola from a given equation. I think I'm going to put together one more video with examples. There was a section in this chapter on identifying from a standard format if an equation is a parabola, a hyperbola, or an ellipse. So I'll take a look at that. And then also maybe an application or two. If you have questions about graphing parabolas that are centered at the origin, those are, that is in a separate video as well. So go ahead and take a look at those.